13.1 vector valued functions. R of t equals 2ti plus 3tj is a vector valued function. We have the parameter t, and if we substitute a t value, we get a vector for a value. So to begin with, we're going to calculate r of 0, r of 1, and r of 2 and graph them. Fairly simple. R of 0, have to plug in 0 for t, and so we get 2 times 0i plus 3 times 0j. We get 0i plus 0j. That's really just the origin. And let's calculate these two before we do a graph. R of 1 is 2 times 1i plus 3 times 1j, which is 2i plus 3j. And r of 2 is equal to 2 times 2i plus 3 times 2j, and that's equal to 4i plus 6j. Now, as far as a graph is concerned, there's x, there's y, and 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, and that's 2, 4, 6, 2, 4, 6. And r of 0, well, that's just the origin. R of 1, 2i plus 3j, we go over 2 and up 3, you can start with a point there, but this is really a vector. It points us to this point. And 4, 6 over 4 up 6. My scale might be off a little bit. Well, we need another vector. And that's r of 1, and that's r of 2. And you can see what happens. We're going to trace out a straight line that goes to the origin. You could sketch r of 3, it would just be further out. R of 4, it would be further out. You could even complete the trace of this line. It just goes like this. Okay, that's a little crooked, but you get the idea. So this has a graph. We can graph the vector valued function. And of course, it has an orientation. As time moves forward, we're headed up this way. Now, we can graph this as a set of parametric equations. Use your imagination. That's x, 2t. That's y, 3t. It's just that these are scalar points, not vectors. So we'll see later on there's an advantage to using vectors. Eliminate the parameter t. Well, we have x equals 2t, y equals 3t. In this equation, we have t equals x over 2, and then you can substitute into this y equals 3t equation. Put this in, and you have y equals 3/2 x. Not surprisingly, that's a line through the origin that has a slope of 3/2. That's exactly what this is. Of course, we lose some information, and we'll see what that information is in the next video. For one thing, if r of t is 2ti plus 3tj, the derivative vector gives you velocity, and the second derivative vector gives you acceleration. So these vectors have specific meaning. You can define velocity and acceleration in terms of scalars, but this vector valued function is just a lot more convenient. So that's all for this first video.